Hello, welcome to our final property assessments project presentation for Computer Science 305. My name is Orion Sehn, and this is my colleague.
Silun Zhang, hello.
Excellent, let's get right into it. We wanted to make a 3D model of the assessed values. To do this, we associated the data given, the x value and the z value with the longitude and latitude, and then the y value with the property assessment value. We sought to make a sort of terrain map that would represent the sort of distribution of the data, so you could get a real physical sense for where the highest values were and how they were distributed. To do this, we used an OBJ file, which is a simple means of storing vector data about objects. They're used relatively regularly in graphics engines and for 3D printers. As you can see on the right is the code for just a simple cubular object. It requires data for each vertex and each face describing the object. To get this information, we had an issue with, we had many points in space, and we needed to describe how to connect to them with some sort of mesh to describe the faces. We also wanted each mesh to be connected to the nearby points to give a sense of an average, and this was a very difficult problem. To do this, we used an algorithm called the Delaunay triangulation. It is a method to connect endpoints together with triangles. And these triangles are then used to represent the faces of the 3D triangle. So this is a demonstration of the Delaunay triangulation. It takes quite a long time, and it's a algorithm that has a lot to do with geometry, and it runs in n log n, which is not exactly ideal. Because of this long runtime, it's not necessarily suitable for very large data sizes. For example, the 400,000 points data sets that generated this image here took about an hour to run. But smaller data sets finish in quite a small amount of time. And once rendered, it opens quite quickly. We implemented a OBJ viewer in JavaFX, so you can view it actually within the side, just within the application. But you can also view it outside in other OBJ viewers, which it typically looks a little better in. Anyways, let us go to the code demonstration part of our presentation.
Thank you, Orion. This is our property assessments application. We added a few new features related to generating an object file and viewing the object file, and changed the CSV file. At the start, ViewGraph in JavaFX and ViewGraph in 3D Viewer both open the object file that's pre-rendered based on a 2020 Edmonton CSV file. Clicking on the ViewGraph in JavaFX will bring us to this screen, which lets us rotate and start and stop the rotation for the JavaFX model. Going back, we can also view it in 3D Viewer. This is a Windows default 3D rendering application that lets us view the 3D model. In here, we can rotate it, and we can also zoom in and zoom out. This model is also clearer than the JavaFX model. In the application, we can also search. We can search by downtown, and it'll give us a sample size of 9,900. This means we can generate a graph, and then we can view the graph that's generated. This is a newly generated graph. If we do something like neighborhood is downtown and assessment class is farmland, it'll have an empty data set. This will make it so you can't generate a graph and give you a warning you that the data set is not big enough. And if you only do a search with non-residential, it'll have a data set of 22,000. This means that it'll take some time to generate, and it'll give you a warning you that it'll take time to generate. If you click reset, it'll reset everything. And it'll make it so ViewGraph, both ways, will view the sample object file again. The last function we added was the CSV file changer. For this, we can enter a CSV file name, and we can click the button to change the CSV file. You can see that the sample size has changed, and we can also generate a graph for it. We can also view this graph in the 3D viewer. And this concludes our application demonstration for our project. Thank you.
Thank you very much, Silun. Yeah, so I would like to talk a little bit about the output of our program. As you can see, it's a little bit difficult to orientate where exactly you are in the city from the just the graph given. It's just there's no map overlaid over it, which is a weakness, but there are some really interesting conclusions that you can still draw from this 3D rendering. The group there's very clearly a grouping of the higher values in the center of the city, and those values that are very high are much higher than the rest of them. And there's quite a bit of disparity there, and there's a lot of proportionally near zero values. Yeah, so there were some things that we could have, additionally improved on this project. It would have been great if we could have a map that would go underneath the object file to give some sense of location. There's also an edge buffering step that we could take to make the triangles less obtuse, and it would make it run slower, but yeah, or like 3D printing is another really cool prospect for this project because OBJ files are the kind of files that 3D printers take. So in any event, yeah, I'm quite proud of what we've done, and here are our references. And thank you so much for listening.